I'm the Director of Webinars for IBM Systems Magazine, and on behalf of IBM Systems Magazine, I'd like to welcome you to our presentation. We will be holding a Q&A session at the end of the webinar. You may ask a question at any time during the event by entering it into the Q&A panel. If you experience technical difficulties during the webinar, please use the Q&A panel to alert us, and someone will assist you. Today's webinar, the GDPR Aftermath, How Lack of Real-Time Alerts Can Cost Millions, is sponsored by CorreLog. Our featured speakers today are Tony Perry and Peter Mills. Tony serves as marketing lead and researcher at CorreLog. Tony's most recent corporate role was Vice President of Global Marketing for ASG, an enterprise-sized software vendor serving both mainframe and distributed markets. Peter's the Vice President of Development and Support at CorreLog. He has more than 39 years of enterprise experience in information technology. Peter has a proven track record of implementation and integration with enterprise-class systems. The ability to discover breaches quickly is crucial in today's security environment, and with GDPR, it's imperative for most companies. So without further ado, I'd like to turn the presentation over to Tony. Tony, you now have the floor.
Thank you, Janine. Thank you, everyone, for joining us. Today, we're going to talk about the GDPR aftermath as it affects states' legislation here in the U.S. There is a ripple effect from what they're doing over in the European Union to what the United States is doing here. Our agenda today, we're going to give you a refresher on the GDPR. We're going to talk a little bit about data that hackers want and where it's located. Time to discovery, we'll talk about the federal government and state government checking in. We're going to do a use case of the Ticketmaster UK breach that happened a couple of weeks ago and talk about the mainframe security gap and how you can bridge that gap with CorreLog products. The GDPR is here. If you didn't know, the GDPR went live on May 25th. And it's an acronym for the General Data Protection Regulation. It is law and originated in the European Union, designed to protect the personally identifiable information of European citizens. And these are European citizens no matter where they reside. The GDPR's coverage is ubiquitous. A simple picture on Facebook could be considered personally identifiable information. Fines can reach up to 4% of your annual global revenue, and the 4% is usually only going to happen to habitual offenders. The first time you'll probably work with the supervising authority. If it happens again, probably 2%, and then as you escalate your repeated violations, that's when you're going to see the 4% penalties. The big stickler for the GDPR is the 72-hour time limit. As you know, if you're up to speed on what IBM does in sponsoring PONMON research on data breaches, the average time to discover a breach in 2017 was 197 days. So this is going to be a problem. It's a problem now, and it's going to be a problem moving forward. There's also a clause in the GDPR for third-party data that might just kill data brokering altogether, and we'll talk a little bit about that as we move forward as well. As most of you are IBM ZOS resources, we believe, and you probably do as well, that the battle lines are going to be drawn for the GDPR on IBM ZOS. It's the workhorse for banks, it's the workhorse for healthcare, it's the workhorse for government. These stats speak for themselves. Your mainframe has the data criminals want. It's got all of the credit card data, it's got insurance data, it's got healthcare data, which happens to incidentally be the most robust data out there. If you think about how long it takes to go to the doctor to have a procedure, it's because all of the paperwork that's involved. You think about all the other people in your life that are connected to your medical records. You think about the payment data within your medical records and work-related data in your medical records. If you are in healthcare or insurance, you need to be concerned about the data that you host on your mainframe. ZOS is also the mobile transactions workhorse. Many of you probably know that IBM has a partnership with Apple, and they are using the mainframe for encryption and artificial intelligence for building mobile apps on mobile devices. And mobile app development and mobile app usage on the mainframe was a big push when they made that partner announcement. Essentially, the mainframe is not going anywhere. We do have evidence of mainframe hack. These are just 2 of them in the past 10 years. And it should be noted here that when a breach happens, it's very difficult to be informed of what happened to the breach because these companies that are getting breached want to protect their brand. We all know Philip Young. We all know he's a pen tester, and he did a webinar with us last year. And it's not hard to hack a mainframe if you know what you're doing. The problem with the mainframe for securing data is that if you look at the architecture of a security information and event management or SIEM system and its accompanying security operations center, these are systems that were all built on Windows, Unix, open source systems. The mainframe is a system that's not native to those systems, and the data usually comes out of a mainframe at idle periods like a nightly batch report. And if you're looking for real-time event notifications and alerts from your SIEM, it's very difficult to get those from the mainframe. Considering that the GDPR has a 72-hour rule to report and the average breach took 197 days, this should be very concerning for you folks that have a mainframe that want to put that data alongside your Windows Unix data in your SIEM. We'll talk a little bit about that again later. These are the last 3 years of data from the IBM Ponemon breach report. You can see that we did a little better on the right side. Time to discover breach from 201, we got it down to 10 days in 2017, and it just ballooned up a little more in 2018. Regardless of how it's performing over the last 3 years, we're talking over 6 months for time to discover a breach on average. Coincidentally, the average cost per stolen record has gone up in the past year as well. Let's talk a little bit more about time to discover breach and the use case on the UK Ticketmaster breach as well. As I said earlier, this is the stickler with the GDPR, the 72-hour rule, especially when you consider mainframe data does not get into your SIEM in real time, and the average time to discover is over 6 months. You have 72 hours with the GDPR to report a breach, to notify the supervisory authority. And I got to tell you, this is going to be difficult. Let's take a look at some other breaches that we do know about that have happened here in the U.S. These are breach timeframes for the discovery. There are 4 here: Target, Anthem, Equifax, and Heartland. And we're looking at nearly 500 million records here. And in at least 2 of these breaches, someone raised their hand very early on in the breach, Target and Anthem, that, hey, we have a problem. And it still took 42 days for Target. We know what the massive amount of data exfiltrated from Target was. And then it took it took Anthem almost 2 months. So clearly we have a problem. Clearly, this is a lot of data that's been exfiltrated. If you're worried about your PII being compromised, don't worry. It's probably already in somebody else's hands. In the U.S., the federal and state government's patience is running out. We're going to look at a couple of use cases, but there are already 11 states out there with data protection acts or data protection laws. And this comes from the dataprotectionreport.com. You can go here. Here's the URL. You'll get the deck. And when I talked earlier when we kicked the presentation off, this is a trickle effect from the GDPR and some other legislation that has been out there for a few years. Let's take a look at North Carolina and California. The California Data Protection Act is called the Consumer Privacy Act of 2018. It is not enacted yet. It goes into effect January of 2020. And if this sounds familiar, it is. It comes directly from the GDPR, and it's designed to give power back to the consumer. The consumer, under this law in California, has to know what data has been collected, how that data has been categorized, and you have a requirement in California as of 2020 to request to stop using their data, and then you have to prove that. It targets organizations that sell personally identifiable information of 100,000 or more records or devices. So that's interesting that they throw devices in there. Or if you have 50 million in annual revenue, or if you get 50% of your revenue overall from using and selling PII. You know, when I read this regulation a couple of times, and it sounds like they're targeting the Amazons, LinkedIn's, and Facebooks of the world, but we're not here to discuss that. That's just kind of a caveat here. Other attributes of the California Privacy Act, businesses can be subject to civil damages of up to $7,500 per violation. Now, there is a 30-day cure period where if someone lodges a complaint, the state of California will give you 30 days to become compliant. And even after that date, if you're not compliant, you would get the penalty. You know, there's additional civil penalties that could be lodged that could be between $100 and $750 per incident. You know, if you've looked at some of the breaches and amount of records that were exfiltrated or compromised from that slide I had shown previously, we're talking about a lot of money here. Businesses do have some protection. From what I've read, it's going to be difficult for consumers just to lodge a complaint. They are going to have to jump through a few hoops. I have a copy of this regulation. If you email me or put a note into the question box, I'll get it over to you, and note that that does consent me to use your data. The North Carolina statute is called the Act to Strengthen ID Theft Protections, or ASITP. It's an update to the current North Carolina data protection law from 2005. And again, this is another one that gives the consumer greater control. Think GDPR. So the consumer in these two statutes and in others we're going to see in the United States, the consumer is going to be given back the power to control their data. There's not much known about this statute. It's being written and sponsored by Jason Sain, a legislator in North Carolina. What we do know is that it has a 15-day breach notification mandate. So given that it's taken over 6 months to discover breach, this is going to be another one that's going to be difficult to adhere to. It also has what's called trouble damages, where if the consumer gets awarded damages from the state, trouble damages means they will just multiply that by 3. If you get awarded the state $50,000 for some company that has compromised your data, that fine gets trebled to $150,000. You've heard it before. It's not if you're going to get breached, it's when. Let's talk a little bit about some other considerations with the GDPR that will affect us here in the United States. You know, the most important thing from this slide is get your legal team involved now. Review and understand what your cyber insurance covers. Have your legal team advise your business side of your organization what's involved in these laws and statutes. And don't forget, the GDPR set a precedent for giving consumers back the power to their data. And when these statutes get implemented, they're not going to be playing around. Let's talk a little bit about Ticketmaster UK and how that affects us here in the U.S. The Ticketmaster UK breach was first mentioned on their website in June of 2018. And as you know, this is after the GDPR went into effect. Ticketmaster UK did not discover the breach. Monzo, a mobile banking financial institution, reported it to Ticketmaster on April 6th. Ticketmaster did some internal investigations and discovered no breach, and also reported that no other banks that they work with had a breach. The GDPR went live on May 25th, so if we look at the time that spanned both pre and post GDPR, Ticketmaster UK has a problem. Their fine could be £500,000 or £17 million, depending on what the European Union does for their fine. And if anybody knows anything about governments, it's probably going to be the latter. It's probably going to be the $17 million. If we look at the time to discover breach as being 6 months, you guys all out there need to get a handle on your data and understand who's accessing it, so that when these laws come into effect here in the United States, you don't get caught in a scenario like Ticketmaster where you're part of a pre- and post-breach scenario. Other attributes of the Ticketmaster breach: Ticketmaster has admitted to it, and they have agreed to offer consumers as much as £5,000 per each for compensation, we're talking about a huge fine here. And remember, GDPR says 4% or 20 million, whichever is greater. So it's not a 20 million limit. On the bright side of things, quote unquote, Ticketmaster only took 78 days to discover the breach, which is actually good considering the average. But if they had done something when Monzo raised their hand and said, hey, you have a problem, and figured out and done their investigation before the GDPR went into effect, they would not be worrying right now about £17 million fine. They'd only be worrying about $500,000. And I can promise you this is going to come up in the United States when the California law goes into effect and the other laws go into effect. There's going to be many instances of pre and post breach, and you're going to, I promise you, want to be fined the pre-breach scenario. Other Ticketmaster takeaways. The hack originated from a Ticketmaster supplier, Abinta Technologies, which was their support provider. Ticketmaster says no North American records were compromised. Magic Heart Hacker Group is allegedly responsible, and as we saw about a week or two ago, they are allegedly responsible for a British Airways cyber attack that affected about 400 customers. Again, Monzo Bank notified Ticketmaster in April. They couldn't find anything, and so we have an instance of a pre and post Ticketmaster breach. Ticketmaster is just the first. The GDPR just went out. We don't really know of a whole lot of others. They're not publicized and socialized, as I said before. A lot of times when these breaches happen, you don't hear a lot about the breach unless it's a high-profile company. But these laws and regulations are coming to the U.S., and you don't want to be caught between pre- and post-breach scenarios. Let's talk about how you can give yourself a cyber fighting chance. But first, we need to talk about what's going on in the organization at the higher levels of your organization. For many years now, analysts from Gartner and Forrester and other industry analyst groups talk about the clash between the business side and the IT side of things, and how the IT is, quote unquote, a slave to the business. Well, now we're injecting another title into the mix, the Chief Marketing Officer. The CMO is actually taking data from the CIO and the CISO, taking budget, from the CIO and the CISO these days. And they're using that data or that budget to buy data-consuming applications such as CRM, marketing automation systems, data subscription services like Discover.org and RainKing, and also new tools called Intent Insight Software, where cookies on websites track your activity and send to these applications signals of who's researching what types of products, time frames they're researching those products, and they're actually giving businesses indications of people's intent to buy things. And software is a big part of this Insight software tool. So these are also applications that are being purchased by the Chief Marketing Officer. The Chief Marketing Officer in large enterprise organizations is becoming a critical player in the management of big data. That's moving away from the IT side and into the business side. So you need to understand this and understand, are the senior level executives in your organization communicating about how they're handling this data, and what are they doing about it from a compliance standpoint? All of these data laws and standards like PCI DSS, HIPAA, GDPR, FISMA, GLBA, and others all have common denominators. They're here to protect the data. And these statutes that are coming out in the United States that we're going to see over the next couple of years will have similar attributes. You'll have to know what data sets you have that apply to these laws and standards. You'll have to have visibility to those data sets. You'll have to secure those data sets. And you'll have to also understand that the consumer now has the power. They can request what data you have on them. They can request you to remove that data, and then you have to provide proof that you have removed that data within certain time frames. And then all they have to do is lodge a complaint to get the penalty process rolling. Visibility in real time is going to be critical for you to manage and maintain your budgets within these laws that are coming out for data protection and security. And to muck the waters up even further, the federal government is starting to get involved. This came out just a few days ago that the federal government is now looking at national breach notification laws that would, I'm not sure how it's going to work for overriding state legislation, but it's certainly going to make the waters a lot darker and make it a lot more confusing. Again, your business leaders, your legal teams are going to have to understand the state laws that are coming for data security and also understand the federal laws for data security and to help you be able to navigate that. Let's talk about bridging the gap that we have with that 197-day breach notification with CorreLog. As we talked about earlier, the mainframe security gap is a problem created by these security systems all built on Windows, Unix, and open systems, and the mainframe not being a native system to those. It cannot get real-time data into the system. How CorreLog does it is through a software agent that's placed into a mainframe LPAR or multiple mainframe LPARs, intercepting all of these subsystem logs that you see on the left, filtering, injecting them into a correlation engine where you can visualize that in the CorreLog visualizer, it's a product CorreLog has, or any other SIM, Splunk, Dell SecureWorks, ArcSight, QRadar. There's not one that CorreLog hasn't integrated within. And through that correlation, have the ability to issue notifications through emails, SMS, text, or also a trigger for a help desk ticket. Peter's going to show you a notification on a watch, on an Apple Watch here shortly. And then feeding that data into the SOC, the Security Operations Center. And then the criticality and the importance of this is that with this agent, you're able to correlate mainframe events alongside distributed Windows Unix events for a holistic view of anomalous activity that could be interpreted as a cyber threat, and then immediately send a notification. CorreLog's products are ZDefender for ZOS, DB2 for DB2, and ZDefender Visualizer for ZOS. Think of ZDefender for ZOS as monitoring and watching operating system access and port access to that operating system. DB2 you can think of as monitoring and watching the data sets within ZOS and on the mainframe. And ZDefender Visualizers just presents that data in a nice, beautiful web-based browser. All the CorreLog products are built with compliance in mind, and we have out-of-box compliance scorecards for each of these, PCI DSS, GDPR, HIPAA. I've said this before, I'm a firm believer that if it weren't for compliance mandates, nobody in an enterprise IT organization would give a flip about security, but that's just my personal opinion. CorreLog ZDefender for ZOS, it'll deliver real-time notification to any Windows Unix-based SIM, including Splunk. It monitors and intercepts these subsystem log events, RACF, CAACF. I'll read them all. I'll let you read them all. It'll also intercept events from BMC, CompuWare, and Micro Focus, as well as application logs from other applications. Strong integration with CorreLog. They've been doing this for over 10 years. The most recent integration and partnership is a technology partnership with BMC. Everyone in this webinar knows who BMC is. And this is a very, very good move for both BMC and CorreLog with the amount of data that they can move over from the mainframe into distributed SIMs, including Splunk. CorreLog will also be in the BMC booth at Splunk Conference 18 in Orlando on October 1st through the 4th. If you happen to be in Orlando for the Splunk Universe Conference, please stop by the booth and get a demo. If you can't, reach out to us on the website and we'll get you a demo, and so you can see CorreLog and BMC working together, populating data into Splunk. CorreLog also has an instance of ZDefender and other mainframe security products within Splunkbase. If you go to Splunkbase's website and just type in CorreLog for the search, you'll see the CorreLog applications on Splunkbase that you can download and visualize CorreLog activity within the Splunk UI. CorreLog DB2 is specific to DB2. It will monitor all of the activity on DB2 as well as any attempts to view activity on DB2. And this is very important for, as you know, privileged user access and monitoring. A privileged user can go in and wipe any record of them going in and looking at data sets, and CorreLog monitors that as well. ZDefender is a visualizer tool. It'll give you a nice UI for visualizing events from ZDefender and DB2 in a standard web browser. The dashboards are easily configured and also provide correlation rules, as I said before, so you can correlate events from ZOS and Windows and Unix and other open systems within a single UI. We're running on schedule pretty well here. I'm going to turn it over to Peter, and Peter's going to talk about the mainframe product a little more in detail, provide several use cases, and also show you a demonstration of the product. Peter?
Thank you, Tony. I'd like to remind everybody, if you haven't already put your slides into full screen mode, you should do so now, just so that you can see the detail on the presentation that I'm about to give. So let's talk about mainframe SIM. We're going to do the product demonstration. There's two aspects, as Tony was talking about just now. We've got the ZOS agent that runs under the LPAR that gathers all the data and sends it to a target SIM, no matter what that could be. And then we've got the visualizer for ZOS, which is where we put all the visualizations and the smarts into what we do with that data. So this presentation is going to be a little bit of ZDefender on ZOS, but mostly you're going to see everything in the visualizer. Okay, so this is the home screen on the visualizer. As you can see, it's called the Dashboard Collection for ZOS Systems, and it's basically our SIM product that runs on the Windows system, and it's pre-packaged with all the visualizations, all the dashboards, the correlation rules, and the alerts specifically designed for a ZOS system. So let's take a quick look through the primary tabs. We're going to look at this first one here. It's got dashboard. So this takes you into the dashboard set. Many people would have this as their default logon. So as soon as they log into the system, this is what they see. And of course, we can have customized logons so that you might have a general administrator like this would see everything. You might have someone who's just a RACF administrator. They would log in and only see the RACF dashboards. You might have a KICS systems programmer. They would log in and they would only see the KICS dashboard. So you can fully customize it like that. The navigation of the product is pretty consistent. You have the ability to drill down into specific messages that generate the data that go into the dashboards. And you can do things like click on this zoom button, this one here, to zoom in to display the dashboard in full screen. So you could have, like if you had a security operations center, you could have some of these dashboards on a big monitor up on the wall. You can minimize that and then go back to the main screen. You can see here the pie chart. We can zoom into that. And all of these dashboards are animated, so when you mouse over the segments, you'll see the segments moving, and you can drill down to see the data behind the segments. You can also turn these segments on and off. If the big segment there that maybe showing 75% of the data, you can shut that off and then just focus on the rest of the data, things like that. So let's close that. And then we're going to go to the Messages tab. So these dashboards are all fed by the raw messages that are coming in from the target LPARs that we're monitoring, the devices. You can have as many LPARs as you like, all feeding into the dashboards. Here you can see the raw messages. Our prime source of data is coming from SMF records, but as Tony said, we're monitoring log files and console messages and job logs and things like that. So we can get data from a variety of sources on the mainframe, and we always identify that message type in the SIM presentation here. And you can see there's the device address, we've got the facility code, and you can see the severity of the message. And the header and this information that we present here conforms to the distributed BSD syslog protocol message. We also have a keyword index because as the messages come in, we're processing them in real time. And every single word of every message is parsed and indexed so we can find it later. On a busy mainframe, busy LPAR, you could be sending 100 million messages a day or more, And when we want to work with that data, for example, the RACF logons dashboard, we don't want to have to pass through 100 million messages looking for RACF logons. We already know where those logons are because we've already pre-parsed them in real time, we've indexed them, and we know exactly where they are. So this index, when you click on there, you can see a summary of every word of every message that has ever been received. There you can see, for example, the word abnormally has occurred 15 times. So we can click on that and drill down to the raw messages, and there you can see the highlighted word abnormally, so you can see that's occurred. You can see every message where that's has occurred. Now these messages, you can't see it here, but every word in those messages is a hyperlink. So if you see a user ID or a dataset name or anything else that's of interest there, you can just click on that word and it'll immediately list every message that has that same word within that data. So it's very easy to do your forensic analysis to drill down and see what's going on. Now you can, if you see the match phrase there, you can type in a string. In this case, I put my name in there, and then you hit enter. And again, it drills down to the data, searches instantly through all the indexes, pulling out every single message that contains that string. You can analyze recent messages. I'll click on that. The default display is for devices, so this list is by devices. And you'll see over there you've got the span of 5 minutes. You can drop that down, change that time span to anything you want. And whether this is the device display or the users, when you see a device ID like this or a user ID, you can just click on it and drill down to see all the messages that have been received from that device or that particular user or facility code or whatever else you're displaying there. So correlation. The reason we use correlation threads is because with the massive volume of messages that are coming from ZOS, like I said earlier, you're getting 100 million messages per LPAR per day or more. That's a lot of messages to be flying by, in your dashboards or looking at them in the message stream. If you're not actively looking at those dashboards, you're not actively looking at those messages, you're going to miss them because they fly by pretty fast. You're talking, tens of thousands of messages per second. So what we do to make it easier for you and to help us do the automation for the alerts and things is we've designed these correlation threads that are looking for specific patterns in the messages. For example, we're looking for, in this example there, number 4, we're looking for console messages. And you can see we've had 6,500 console messages today, or at least when I did this screen capture. And then the one below, number 11, that correlation thread was looking specifically for APF alerts. So there's a number of factors that you can put into the correlation smarts. You can say things like, well, are they accessing an APF authorized data set? Yes. What are they doing? Are they just looking at it, or are they updating it? Did they do an add replace? Did they copy a load module into that library? And then what are they going to do with it? So you can put all those factors in and then generate the alerts from that, or put that into this thread. And once you've got that thread, you can then use that data to put on a dashboard or use it in an alert or whatever. And you'll see some of that in the demo in a moment. So let's go to alerts. So for each of these alerts, we define some rules. For example, this one is APF authorized library updated. There's a couple more there, warning Db2 catalog tables, sensitive data accessed, or multiple TSO logon failures. If you look a little bit to the left of the arrows, you'll see the threshold where we say greater than or equal to 1 in 30 seconds or 3 in 60 seconds. So that's where you set your thresholds for what constitutes an alert. If I just see 1 TSO logon failure or 2 logon failures in a minute, is probably no big deal. But if I see 10 in 30 seconds, then probably that's something worth investigating. Now, when we create these alerts, when alert has been triggered, so you've got the raw message that came in, we analyzed it, we put it in a correlation thread, the alert rules kicked in and said, hey, there's something going on here you need to know about. So from that, we create these tickets. So tickets can be assigned to a particular department or an individual. And when this happens, you need to let people know about it, of course. So then we've got these ticket actions. Here's an example. You can have multiple actions. I've got 4 in here. The first one is to send an email to somebody. In this case, it's going to the operations department. Then you've got sending related messages to another system. So if you already have another SIM system in your system, you might have Splunk or QRadar or ArcSight or RSA or any other SIM out there, we can also forward those messages. So think of this, you've got your big busy LPI, you've got 100 million messages coming in. Do you really want to put all 100 million messages in your Splunk system? Maybe not. So what you can do, put the visualizer in place, have all those 100 million or more messages coming into the visualizer, and then just forward the alerts, the real data that you care about, that you want to investigate, have those forwarded to your Splunk or other systems. The third example there is an SMS text message. So, the alert gets fired, I create a ticket, I sent out the emails, but this is pretty high importance, so I'm going to send an SMS text message to someone's cell phone or their Apple smartwatch, their iWatch, so you can say straight away, hey, this is something you might need to investigate. It's better than getting a report the next day or the end of the week. And then the last one is, in addition, we're also going to send an alert to another help desk system. So you might have BMC's Remedy or ServiceNow or some other product. So as well as our little ticketing system here, you might want to push it to another ITSM system. So let's take a closer look at some of the dashboards, and you'll see how useful this data is once you start managing it. So here we've got the overview, and as I said before, depending on your logon, you could come into this overview, or you could go straight into Db2 or straight into RACF, or whatever your area of interest really is. So this dashboard here is a summary of all the console messages. You can see the first panel there. We've got default messages, RACF, security, JES2, etc. So we put all of the system messages, the syslog messages coming from ZOS into these buckets to make it easier for you to manage. And of course, you can monitor those and alert on them just like any other message. Then in the middle, you've got the security messages, then critical messages, the ZOS health checker messages, Db2 messages, etc. So you can fully customize how you want to split up your messages and manage them. Then Db2. These are all the Db2 messages. We've split these up into different categories. You could have, like example, the first dashboard there, administrative actions. So I want to know who has the administrative authority, and that's presented or notified to us through IFKID 361. So we turn that trace on to monitor that, and you can see exactly who has administrative authority and who's doing the work behind the scenes, like the inserts, updates, deletes, that are probably doing work outside of a normal transaction. So if someone logs on to Kix, for example, and they go into some application, they do the work, you can usually trust the application that they can only do what that application allows them to do. But if someone has admin authority and they go outside of those applications, they go into Spoofy or IBM's Data Studio, and they're running their own queries, they could potentially be doing some damage, and you need to monitor those. You need to see what they're doing. So over on the right there, you'll see down on dashboard number 6 there. Here's an example where we're monitoring audited tables. So any table out there that has the audit clause on, and this example, we can see that someone did an insert into this table, into an audited table, so we can drill down and see what's going on. There you can see the actual SQL statement, so you can see exactly who did what to what table. You've obviously got the user ID, the auth ID they connected with, and everything in the data just above that. So now we're going to look at the file integrity dashboard quickly. There you can see things like dataset scratch, modified PDSs, members that have been modified. On the bottom row there, you've got GDPR datasets access, PCI datasets access, that kind of thing. And then on the far right there, you've got the APF alerts by DSN. I'm going to show you an APF alert shortly. So jobs and sessions, let's click on that. Here's a summary of all the jobs and sessions that are running on your system. You might be interested in started tasks that shut down. You might be interested in anyone who's running a job to do a ZAP to a load module, probably something that not many people were doing, but when they do it, you want to audit that. So we can do things like that. The RACF dashboard there, you can see things like all the failed logons there. You can see accesses to sensitive data sets. Anyone that has RACF special or operations, you can see what they're doing. You can have a summary of violations, and on and on. These dashboards actually scroll down. You can only see 6 in this presentation, but you see on the far right there's a scroll bar, so you could go down. There's more rows of other dashboards. And the tabs across the top there, you can create your own dashboard summaries, and it's up to you which individual objects or gadgets you put on each of those dashboards. So TCP/IP, we're monitoring TCP/IP traffic. IMS, we're monitoring IMS log records. They don't go through SMF, so we get those separately. Again, all dynamically, and there you can see a summary of those records, security violations, logon failures, and things like that. Then KICS, we have a full complement of KICS dashboards. We're looking at who's using what transaction. We're looking at the performance and resource class messages. We can see what files are being accessed by those transactions and the users of those transactions. And on the bottom right there, you can see anomalous behavior. We have the ability to track trends from users. So if a user does a certain thing most of the days, and then one day he comes in and he accesses a transaction he's never accessed before, then we can alert on things like that. I'll talk about the GDPR scorecard in a moment, but let's quickly go to the next tab. We've got our security dashboard here. You can see we support RACF, ACF2, and Top Secret. There's a drill down into some ACF2 dashboards, Top Secret. And then we've got some performance dashboards as well. We're monitoring all the RMF records. We're doing the SMF type 30 interval stats, and we're also looking at some hardware stats, type 113. So let's talk about some use cases. Use case 1, failed logons. Here you can see over on the right, this is my RACF dashboard. The failed logon screen there is empty. So someone comes along and types in, I want to log on as someone called GDPR. That user ID is not authorized to use TSO. And then they log on with a real user ID, but they get an invalid password. So there you can see the 2 alerts over on the dashboard, the GDPR and the other user ID with the password failure. You can drill down to those. There you can see the RACF init, undefined user ID, event code 1.9, and there's the user ID they attempted to log on with. For the second one, there's the event code 1.1, and you can see the invalid password. Use case 2, privileged Db2 user. So there, the dashboard is empty. So someone comes along. Let's click there. Someone comes along and runs a query against the Db2 catalog table. The sysIBM sysuser auth is a table that allows you to see who has privileged authority. So who has sysadm, who has dbadm, and so on. So they run that query. Did they have a good business reason for running that, or are they up to no good? Do they want to know who are the privileged users in DB2? So straight away we will log that. Someone's accessed that, and you can drill down and see the data. There you can see the exact query that was executed, and you can see who did it as well. Another use case, escalated SAF privilege, and this obviously we support RACF, ACF2, and Top Secret, and you can see here. I'll click on there. Let's say someone comes along and browses a data set here. This one happens to be an APF authorized library, but it could be anything. So they go and look at that. There's the library results, and there you can see it was DS input. We just browsed it. It was record type 14, and there's the security status of that particular user ID right now. So we look at the ACE control block from RACF, and you can see that we flagged that user as a normal user. Well, let's say as if by magic, the same person a few minutes later or seconds later, they go back and look at the same library or any other library, and this time we've issued an alert, because if we look at the data, same record type 14, so they're still looking at the data, but notice the ACE flag has changed. Now they've got RACF special. How did they do that? Did they run a little batch program that happened to be APF authorized and it went into the control block in memory and flipped a bit to give them RACF special? Maybe they did. If they did, you certainly want to know about that. So we adjust the data that we're sending out. This is part of what we call our SMF enrichment. We're not just gathering data from SMF. We enrich the data with other information that makes the data more powerful for you to use. And in this case, we've added this PrivStatD warning escalated privileges. So you could set up a correlation thread and alert on that and let people know someone's just escalated their privileges in RACF and they really shouldn't be doing that. Or if they did do it, how did they do it and why did they do it? Did they have a good business reason or are they up to no good? And there you can see the alert that was generated. So we have an alert monitoring, are any of these records present in our system? Anything coming in with that escalation privilege warning? And there it is. And you'll see that the alert turned red. And there's the message. The user has attained escalated status. You need to go and investigate that. Another use case, file integrity data. We talked a lot about with GDPR, about PII data. So let's say someone goes and browses a data set. I've named it GDPR.social security number just to make it easy. And you'll see there's a data set. It's got some social security numbers in. People go in and edit those or look at them. There's the alert in the GDPR data set access dashboard. And we can drill down and see the data. There's the type 15 saying the data set had been open for output. And there's the data set name. So again, you can drive alerts with that. The last use case I'm going to show you here is an APF library update. Here you'll see we are copying a module to the CZ agent load library, which is APF authorized. So someone has written this program from another library, and I've selected it and copied it into that load library, into that APF authorized load library. So the first thing you'll see there in our dashboard, we've got the APF alert by DSN. You can see there's the alert, and we color code these reds. The alert, the red ones are something you need to pay attention to. Of course, you can choose any color. And there's the message. You can see that we've got all the information about the access to that file. So you can see there was the action. It was an add replace. You can see the member name was PM14. And you can see that little flag there, APF yes. That's another one of those SMF enrichment fields that we add. We've got that from a different control block. We didn't, we don't get that from SMF. SMF doesn't give us all that kind of information, so we work that out for ourselves. And we added that to the message, so it's very easy for you to create a correlation thread or an alert based on accesses to any data set name that has the APF yes flag that we would get from our message. So there's the alert, as you saw before with the privilege escalation before. The alert's gone red, and there's the authorized library updated. That tPars DSN is a variable that says when we send the alert, we want to substitute that with the actual data set name. And there's the ticket that was created, and you can see APF authorized library updated, and there's the data set name that we extracted from the message. And then there's one of the rules. Rule 3 is send an SMS text message. And then there's the message that got sent to your smartwatch to let you know something's happened, you need to go and take a look at it. Much better than having a report at the end of the week or the end of the month. You need to know right now. And as Tony said, you don't want to wait 197 days on average to find out that someone's up to no good. You need to know within seconds that they're up to no good so you can stop them and investigate them straight away. So let's talk about data masking. It's a big issue with GDPR is privacy and the PII data that may be present. Now, as a rule, we're not sending raw data down to the SIM. We're only sending activity about accesses to the data. However, there are instances like when you're trapping SQL messages, there may be some PII data inherent or included in that SQL message itself, in the SQL statement. Someone does a select on customer table where customer name equals Joe Blow, then you're going to see that in the SQL statement. So we have the ability. Now on the ZOS agent, you can filter out all of the data you don't want to send. Every single field that we send is fully customizable. So you can say, don't send this field, it might have sensitive data in it. You can eliminate that. But if that's unavoidable and you do send data, then we have these masking rules down on the visualizer. So here's a masking rule. You can see message config overrides text, where I've said, if in my test message, of course, I see something called masking test, and then I'm going to look for a value there, administration, social security number. So ADM, SSN, and there's going to be a value in parentheses. So when I get a message using that and that, over here you'll see this message. I'm going to send a sample message that looks like, you know, test message ignore, masking test, and there's the social security number. So I send that message to the SIM. As soon as that message is received, the masking rule is executed, and then you'll see there the social security number has been replaced with the hash signs, and we add the little text on the end saying text override rule number 4, so you know exactly why this message was updated and overridden. Okay, compliance scorecard. I just want to show you a little bit about the compliance scorecards out of the box. You'll see in our report section, we've got these scorecards over here. You can click on that. And we've got out of the box, we've got scorecards for CGIS compliance, you know, IRS Pub 1075, ISO 27001, SOX, PCI DSS, etc. But for now, we're going to look at the GDPR, and this is for our mainframe customers. We're looking at the mainframe events. So here's the scorecard. The scorecard is basically a template where you put in all of the rules, and these come out of the box. You can plug these into any system, and we define all of the regulations, all of the requirements from the specific compliance body that we're after. So in this case, you see the ones for GDPR. This first one says, you know, identification of data stores. And what we're doing is we're monitoring all of the messages coming in, and particularly the correlation threads. So here we're monitoring Z all messages and the GDPR device status messages. Look at the one at the bottom, number 6. We're looking at file integrity and the GDPR audit logs. So these rules are looking, or rather these scorecards are looking for the messages that are in stream through the enterprise to say, are we covered with that particular requirement? There you can see the number of messages we're receiving today, and you can see last 7 days, 30 days, and the daily average. So yes, we can say we're okay with that requirement because we are monitoring those messages. Now the same scorecard we can filter up into a GDPR dashboard. So here in our dashboard set, we can click on that, and there's the dashboards. Okay, so this dashboard is a roll-up summary, and you can use this to drill down into the scorecard and see the original data. So I'm just about done. Everything you've seen right now can be done with other SIMs. I've done it with the visualizer because that's our product. But we fully support Splunk and other SIMs out there, other log message management systems. So whatever you've got, we can send the data to you too. So I'm just going to quickly whiz through some examples of these Splunk screens just to really show you how the data would look in a Splunk system with Splunk dashboards. Now, all of the dashboards I'm flicking through here, we give out of the box. You can install these as part of our Splunk app, and you can go to Splunk base and see what we've got and submit a request to download them from there. But this just gives you a feel for the kind of dashboards that we can provide with other systems. Okay, so there was ACF2, there's Top Secret, there's Kix Performance, Db2. There's the raw data you can put in searches. Here we're looking for all Db2 data, RACF, and so on, performance, etc., etc. So that's it. I hope you enjoyed my presentation. I'd like to hand back to Tony now. We've got about 6 minutes left for some Q&A. Tony?
Thank you, Peter. Very well done. We do have enough time for a couple of questions, on top of what Peter just showed in the Splunk dashboards, if you're going to be at Splunk Conference 18 in Orlando, October 1st through 4th, please stop by the booth. We'll be with BMC. You can see all of the data that BMC and CorreLog together are putting into Splunk. It's pretty remarkable, the things we're doing with those guys. The first question is centered around the GDPR. and it is, can PII be as simple as a name and an email address? Yes, it can be. It can even be an identifier as simple as an IP address. Your Bible for the GDPR online should be eugdpr.org, eugdpr.org. There's some good FAQs there. There's a good overview of the GDPR there as well. And I think the caveat here is you should be concerned about what your marketing team is doing with the big data that they're controlling. They're sending out thousands of emails every week. They're monitoring traffic coming through the website with marketing automation systems. And I'm not sure that all of the marketing people, and I'm a marketing person myself, I'm not sure they realize the compliance strings they hold in their hands when they're working with your big data. The next question is, let's see, where did it go? Well, it's gone. I wonder if people can delete their own questions. The next question would be the GDPR scorecards that you were showing and the GDPR functions within the system. How long does it take to install that that you demonstrated? We also have CorreLog CEO George Foucher, founder and CEO. So George, do you want to take that one? Or Peter, either of you?
Oh, okay, I'll take that. Yeah, the GDPR scorecard is not in the standard install product. It's actually a plugin. We have numerous plugins with the product. So when you first install it, there are a number of plugins, whether you want to, for example, we only showed you the ZOS system today, but we have a number of plugins, for example, adapters to monitor Active Directory and other resources out there. And one of the things you do as a plugin is install all the scorecards that you wanted, and GDPR is one of those. So yes, it is kind of out of the box, but you just install it as a plugin after the main install. Okay.
Thank you, Peter. Another question is, I noticed you had QRadar on your integration slides. What are some of the formats that this product supports coming out of the mainframe?
Okay, I'll take that. So by default, we handle the standard RFC 3164, what they call the BSD syslog protocol message. So those syslog stream messages are consumed by most SIMs out there. But yes, for QRadar, that prefers the leaf format, so the log extended event format. So we handled that. For products like ArcSight and RSA, we use the CEF format, the common event format. And for Splunk format, we have a Splunk format. We also map to the SIM model, the common information model that Splunk uses. So we can handle any format that's out there. We also send out in JSON. If you've got the ELK stack and you want it in JSON, we can send it in JSON as well.
Good. Thank you, Peter. This one is about something, Peter, I mentioned in the presentation, talking about privileged users being able to wipe their tracks, being able to erase things that they were looking at. How does this solution monitor and report on that?
Well, that's a very good question, because we're not just looking for specific activity. We're looking at, data set activity, looking at TCP/IP records. So what we're doing is, and obviously all the RACF records and other SAF records, we can see the big picture. So as soon as you get to the point where you see some specific activity or some suspicious activity, because we've audited everything and it's all in the database, you can use the forensic analysis tools to drill down and see what's happening. So when someone does something that's slightly suspicious, you can go back and see, well, what else did they do, in the last 5 minutes, 10 minutes, 2 days, 30 days, whatever. And you can see a pattern of their activity, and you can see everything they did. So if they went back and covered their trace, they went back into a Palm file, updated something, bounced a started task, you will see all of that activity.
Perfect. Thank you. We have about time for one more question. This is an easy one to answer. Is the presentation going to be available for me to have someone else view later, i.e. recorded? Yes, it will be available. I'm going to throw this over to Janine at IBM Systems Magazine and let her answer that one. Janine?
Hi, Tony. Yes, we will be sending out a follow-up email in the days following the webinar, so please watch for that. And then, unfortunately, we're all out of time for today, so we got some great questions. Know that if we did not get to your question, someone will reach out to you via email. And I want to thank everyone for attending today's webinar. I also want to thank Tony and Peter for sharing their expertise with us today. And that concludes our webinar. Thanks again, and have a great day.